Welcome to TSAT education channel, my dear students. TSRJC ఎగ్జామ్ కోసం ప్రిపేర్ అయ్యేటువంటి అందరి విద్యార్థులకి నా శుభాభినందనలు. ఈరోజు మనం ఫిజికల్ సైన్స్ స్ట్రక్చర్ ఆఫ్ ఆటమ్ ఆర్ అటామిక్ స్ట్రక్చర్, దీనిలో ప్రశ్నలు ఎలా ఉంటాయి అండ్ హౌ ద స్ట్రక్చర్ ఆఫ్ ఆటమ్, ద కాన్సెప్ట్స్ should be understood. Let us discuss in a brief way. Physics and also in chemistry, the atomic structure questions will be asked. The approach is different. In physics, generally the questions will be framed on the basis of quantum mechanics. In chemistry part, the chronological developments taken place in defining atomic structures from atom to electron configuration and periodic classification, such things will be dealt. However, we have this chapter in 10th class. The questions may be from physics approach or chemistry approach. Let us discuss. Structure of atom or atomic structure. The basic part or building block for an element is an atom. The term atom was first introduced by Democritus. Of course, before 460 BC, Kanada is the prominent rishi existed in our country. According to Hindu mythology, Puranas, Kanada evolved the term Kana, that means atom. All the matter which we are visualizing, including our human body, that is made up of the small building blocks or bricks, that is atom. So, different atoms construct a huge particle or substance. So, Democritus pronounced up material in his pestle and mortar until he had reduced them to smaller and smaller and micro, very small particles. He called the ultimate, the last indivisible part as atom. So, he named that indivisible, the ultimate, the last atom which cannot be breaked up further, called as atoma. Atoma is a Greek term that means indivisible. It cannot be divided further. The history of atom from 400 BC to the new era. In 1808, John Dalton proposed a different theory. He suggested that all matter was made up of the tiny spheres that were able to bounce around with perfect elasticity and called them as atoms. This theory is also known as billiard ball theory or billiard ball board. In billiard ball game, the billiard balls will be collide each other. They will not change their shape. In the same fashion, the atoms consisted in the matter, they will move or they will be bounded with other atoms like billiard balls, or you can consider as carom board coins. When we start the game, carom board game, all the coins, let us say the atoms, are bounded together. When you hit with a striker, all the coins will be dispersed and distributed on the board. In the same way, the atoms will collide together. The carom board coin or the billiard ball, the shape will not change even though you hit hardly with the striker. In the same fashion, the atoms never change their shape. Later, after nearly 90 years, John Thomson defined atom in a different way. He found that atoms could sometimes eject a far smaller negative particles, which he called an electron. So, atoms are having electrons, that is negative charge. Why he introduced this concept is from cathode ray tubes experiments. He recognized the matter will liberate electrons or negative charge. So, all the atoms must possess the negative charge and also the positive charge. Basing on the charge concept, Thomson evolved a theory. In the history of atom, the first widely accepted theory is Thomson model or Thomson plum pudding model. Thomson developed the idea that an atom was made up of electrons scattered unevenly within an elastic sphere surrounded by a soup of positive charge to balance the electrons charge like plums surrounded by pudding. Just like the fruit bread. In fruit bread we see the sweety fruit pieces. So, the atoms in an atom, the electrons are located like the fruit pieces in a bread or the pudding in the plum, like that. Or you can consider this as watermelon model. In watermelon, the black seeds will be located surrounded by red mass, red plum, that is all the positive charge. But this theory was no more considerable. Within few days it was discarded because the charges cannot stay stable. The negative charge cannot stably located in the positive charge, as we see the red plum in watermelon and black seeds in the watermelon. So, this is a watermelon model. Then Rutherford evolved a theory covering the drawbacks from the previous one. So, these are the chronological way. In 1898, a theory was proposed. Later, it was modified. Then, some of the drawbacks are covered by Ernest Rutherford. So, Rutherford model is almost the final one according to our chronological developments in the era of history of atom. So, Rutherford was he fired helium nuclei at a piece of gold foil. What is the foil? Gold foil, a thin foil, very thin foil that is countable to 3 or 4 atoms thickness. So, comparably 3 to 4 atoms thickness, that foil, gold foil is taken, and helium nuclei are bulleted or bombarded, gunned towards the foil. They found that although most of them passed through, all the nuclei, helium nuclei passed through the gold sheet or gold foil, and very few diverted or scattered or returned back. Only one helium nuclei among 10,000 nuclei when considered. That means among 10,000 hits due to helium nuclei, one hit is bounced exactly opposite direction. So, he postulated the modern atomic theory. This is the experimental setup made by Rutherford. So, a gold foil is taken as a target, and helium nuclei are taken as bullets. He fired or bombarded the foil with helium nuclei, and the nuclei are scattered. Rutherford new evidence allowed him to propose a more detailed model with central nucleus. He suggested that the positive charge was all in a central nucleus. So, according to plum model or watermelon model, J.J. Thomson model, the positive charge is distributed in the entire atom, and the negatively charged particles, electrons, are located in the positive charge. But Rutherford clearly segregated the positive charge and negative charge, because due to the repulsion of very less number of helium nuclei from the gold foil, he realized that the entire portion in the gold foil, according to the charges, it is empty. So, the positive charge is located in small regions only. Around the positive charge, the electrons are revolving, and the positive charge is centrally located. He named it as nucleus. Later, Niels Bohr made some more corrections to that theory. Whatever the drawbacks enlightened during those days, Rutherford model was modified by Bohr. He studied under Rutherford at the Victoria University. Why I am giving this information? You may be asked a question like that. Niels Bohr is the student of Rutherford. He proposed the modifications, or the drawbacks were rectified. Rutherford drawbacks are rectified by his student, like that. Bohr refined Rutherford's idea by adding that the electrons were in orbits. Just Rutherford tried to explain the electrons are revolving. How they are revolving? If they are revolving in an irregular manner, they may hit one another, and the atomic structure, whatever he is thinking of in his mind, that will be disturbed. But atom is stable, no matter is unstable. In our surroundings, every material, every substance, every object is having, the solid object is having a fixed shape that is not changing, and all the materials are made up of the building blocks that are atoms. So, Bohr explained that the electrons are revolving in fixed orbits. So, this is the Bohr model. See how the electrons are revolving in a helium atom. In an helium atom, two protons, that is positively charged particles, that is mentioned in a positive charge. These are called protons, and electrons. What are these two? These two are neutrons. Helium consists of two neutrons and two protons at its center. It is called nucleus. So, by giving this diagram, a question may be framed like this. Mention the name of the identified or block end part. If this is block end, we have to say it is proton, neutron. Neutron is having no charge, like that. So, proton and electron, neutron, electrons are revolving around the shell. So, names of these parts that may be asked in the question. What do these particles consist of? ఈ పార్టికల్స్ అన్నీ ఏమేమి కలిగి ఉంటాయి? లెట్ us see. Proton, that is positively charged, 1 unit mass it possesses. Neutron is having no charge and having 1 unit mass exactly equal to the proton mass. Electron is having no mass and having positive charge exactly equal to the proton. Of course, proton is having positive charge, the same quantity or amount of negative charge is possessed by electron. Now, how to represent the atom? This is helium. Helium 2 4. 4 is the mass number, 2 is the atomic number. The number of protons in helium. How many number of protons are present in helium? The question may be asked like that. Or in calcium, how many protons are present in calcium nucleus or calcium ion nucleus? Ion, you know, earlier in chemical equations we discussed about ions. Ions means the charged part, charged atoms. When this helium loses one electron or both the electrons, it will become positively charged. Of course, this is a very stable atom. It is almost impossible to remove electron from helium. The number of electrons are exactly equal to number of protons, but the charge is different. Electrons are arranged in every levels, energy levels. It is called energy level. Energy level or orbit or a shell. The first shell or first orbit, it can accommodate 2 electrons. The second shell or second orbit can accommodate 8 electrons. The third orbit, third shell, it can accommodate 8 electrons. There are 2 ways to represent the atomic structure of an element or compound. Electronic configuration. So, in first shell or in first orbit, how many electrons can be accommodated? Let us consider all the atoms one after one: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, like that. In hydrogen atom, 1 electron in the first orbit. In helium, 2 electrons in the first orbit, because in the first orbit there is a space for second electron, but it cannot provide a space for third electron. When the atomic number increases, the third electron enters to the next orbit, that is second orbit or second shell, like that. 2 plus 8, 10, up to sodium. The atomic number of sodium is 11. So, in sodium, the third shell will start, or third orbit. 1 electron will be present in the third orbit, 8 electrons in the second orbit and 2 electrons in the first orbit, like that. We represent these electrons or atomic structure like dot cross model. With electronic configuration, elements are represented numerically by the number of electrons in their shells and number of shells. So, nitrogen. Let us consider example nitrogen. The atomic number of nitrogen is 7, we know. There are 7 electrons in the nitrogen atom. In the nitrogen nucleus, there will be 7 protons. Around these 7 protons nucleus, 7 electrons are revolving. 2 in the first orbit, 5 in the second orbit. There is no third orbit for nitrogen. Now, consider calcium. The atomic number of calcium is 20. So, in the first orbit 2, second orbit 8, 10 electrons are over. In the third orbit, first let us fill 8 electrons. In the second orbit 8 are present. So, in the third orbit also, third shell also, we can place 8 electrons. Beyond that 8, some more accommodation is provided in third shell, but according to some rules, let us discuss later, the 19th electron will enter to the fourth shell, and the 20th electron also will enter the fourth shell. After filling up the fourth shell, partially filling up the fourth shell, again the electrons come to the third shell. That we can understand by writing the electronic configuration. See, calcium is having 20 atomic number, so 20 electrons, 20 protons and 20 neutrons are present. Here sodium, 11 electrons, 11 protons. See what is the mass number here? Mass number is 23. The atomic mass of sodium is 23. So, why it differs with this proton number, neutron number and proton number is differing. When we move further, the protons, number of protons and number of neutrons are not equal. The number of neutrons will increase than the number of protons present in the nucleus. So, the mass number will change, but the mass number is a whole number. That need not be a whole number. According to isotope theory, every element possesses some isotopes. When the isotopes are considered, the mass will be calculated, the mass number or mass of an atom will be calculated according to the average mass of all the isotopes, possible isotopes. In oxygen, there are 8 electrons and 8 protons and also 8 neutrons. Mass number is 16, so proton number is 8, so neutron number is 16 minus 8, it is 8. In chlorine, 17 protons are there, 17 electrons, 17 protons. What is the neutron number? If chlorine Cl 1735 is given and the question is asked how many protons are present or how many neutrons are present in chlorine, how to do that sum, how to find the correct answer? 35 minus 17 proton number. So, it is 18. 18 neutrons are present in chlorine atom. Similarly, silicon, boron. Boron is also having one neutron excess than the proton number. The electronic configuration. So, first shell, second shell, third shell. As I explained earlier, the third shell possesses 8 electrons, but the third shell definitely can accommodate more number of electrons. The electrons will not be filled in the beginning. The remaining 2 electrons, 2 plus 8 plus 8, 18, 18 plus 2, these 2 electrons will go to fourth shell. In sodium, we have 3 shells, first shell, second shell and in third shell 1 electron. Oxygen 2 6, this is called electronic configuration. If a question is asked like this, what is the electronic configuration of oxygen? You can say 2 6, 1s2, 2s2, 2p, 4 like that. Let us discuss it later. Chlorine 1s2, 2s2, 2p6, 3s2, 3p3. So, 2, 8 and 7. In silicon 3 shells, boron only 2 shells like that. With the dot and cross, how to represent nitrogen atom? This is the cross. What it represent? It is electron. Why it is electron? Why not it be a proton? Protons are present in the nucleus, they will not come out. Only electrons will revolve around the nucleus. So, all the positive charge is located and binded in a tiny area, nucleus. So, How many crosses are there? 6 plus 1, 7. So, 2, 3, 4, 5, 6, 7. Now, dot cross model for oxygen. Oxygen atomic number is 8. 2 in the first orbit and 6 in the second orbit or second shell. Chlorine, see, 2 plus 8 plus 1, 2, 3, 4, 5, 6, 7, 8. Okay. So, 17 electrons. 17 electrons are located around chlorine. If Cl minus is given in the question paper, how many electrons are present in Cl minus? Cl minus means it is having negative charge. If negative charge is mentioned, what it represent? It possesses more number of negative charge, more number of electrons. So, we have to consider it as chlorine 18. Cl minus means 18 electrons we have to accommodate in the shells. Similarly, if oxygen O2 plus is considered, 2 plus means the atom lost 2 electrons. If 2 electrons are lost, what is the number of electrons around oxygen nucleus? 8 minus 2, 6. So, we have to accommodate only 6 electrons, 2 electrons in the first orbit and 4 electrons in the second shell. Okay. So, electron configuration will change if charge is indicated. So, generally in the question paper, the electron configuration will be asked basing on the charge Cl minus, O plus plus or Mg2 plus, N3 plus. N3 plus means nitrogen, atomic number of nitrogen is 3. There should be 7 electrons in the atom of nitrogen. If 3 electrons are removed, the 3 units of positive charge occur in the nitrogen atom. So, we have to remove 3 electrons from the electron configuration. Now, the orbits, how the orbits will be seen. This diagram may be given and you have to name the parts or labeling basing on labeling of diagrams the questions may be asked. The location of different parts of atom in a see, nucleus of protons and neutrons. This is the nucleus, red balls and block. Red, that nucleus, the neutrons, and the balls are spheres represented in black color, they are protons. So, electrons and protons. This is dot cross model, nothing but dot cross model. See, electrons are. This is orbital shape or atomic structure, how the atom will appear. If we peep into the atomic model, of course, it is not possible to see into the atom. Atom is the tiniest one. We cannot recognize one single atom. Even with the electron microscope, we cannot see a single atom. If at all we are able to see or we are able to peep into the atom will be appear like this. How this shape is evolved? Basing on some mathematical theories, mathematical equations, it is called quantum theory. The scientists evolved the model. So, how to draw the atomic model, diagram of atom? How the electrons are evolving? These are not the elliptical shapes, my dear students. These are in circular orbits only they move. So, it is not possible to show the circular orbit. That is why for our convenience to understand clearly in 2-dimensional the elliptical orbit is shown, but don't think the electrons are revolving around the nucleus as if the planets are revolving around sun in elliptical orbits. Now, let us go further. What is a proton? How to describe the proton? What is the electron? Like that. Protons are positively charged particles found in the atomic nucleus. Protons were discovered by Ernest Rutherford. So, who discovered proton? The answer. 4 options will be given. You have to identify the right option, Rutherford. Rutherford, Thomson, Dalton, Kanada. If the options are given like that, then you have to select Rutherford for such questions. In which year it was established? The idea of proton is established during 1960s, 70s. And basing on what concept the proton is evolved? It is on quarks. Quarks, it is called particles. See, experiments done in the late 1960s and early 70s showed that protons are made from other particles called quarks. Protons are made from 2 up quarks and 1 down quark. The quark theory is a different issue. Just you remember this word, it may be asked in the questions. Now, neutrons. Who discovered neutron? The first, Chadwick in 1932. That is a chronological age. Years also you have to remember. The nearby years will not be given. 1930, 1931, 1932, like that it will not be given. Generally, the questions, if years are mentioned, 1898, 1908, 1998, 1932 will be given. Then you have to select this one. You need not by heart the numbers, just in a chronological age, how the concepts of this atomic structure was evolved by different scientists in different ways, basing on previous theories. Always a new theory or new information will be abrupted by the old one. If a theory is having some lapses or some drawbacks, then other scientists, the next generation scientists, try to fill the gaps or fill the drawbacks. That's why some questions may be asked basing on this age factor or years, that is history part. Now, electrons. Electrons are negatively charged particles. Who discovered electrons first? J.J. Thomson. How he discovered? With X-ray tube experiment. How the protons are discovered? Using gold foil. So, questions will be asked like that. If you remember the concept, whatever the question is, whatever the distractors or options will be, you can identify the answer very clearly. Electrons determine properties of the atom. Chemical reactions involve sharing or exchanging electrons. This is very important. This is chemistry aspect of atom. During a chemical reaction, only the electron number will change. Electrons will exchange. Electrons will be shared from one atom to other atom. For example, if you consider say water molecule, hydrogen atom will share 1 electron each. 2 hydrogen atoms share 2 electrons present in both the hydrogen atoms to oxygen. So, oxygen takes 2 electrons. It will become rich in electrons. So, electron number will increase for oxygen, and hydrogen will give 1 electron to oxygen, each hydrogen, both the hydrogens 2 electrons. In such a way, the molecules will be formed by sharing of electrons. So, what is nucleus? The nucleus is the central part. Where the nucleus is located? At the center. Where the electrons are present? In the nucleus or around the nucleus or somewhere beyond the nucleus? The electrons are revolving continuously, they will revolve. What will be the velocity of electron? If a question is asked like that, with what velocity the electrons are revolving around the nucleus? It is light speed. What is the velocity of light? 3 into 10 to the power of 8 kilometers per 3 into 10 to the power of 8 meter per second. That is the velocity. With the same velocity, the electrons will revolve around the nucleus. The nucleus contains most of an atom's mass. So, nucleus is considered as massive part. The surrounding part, whatever the wide area surrounding the nucleus, that has no mass at all, because electrons are having almost very negligible mass. Do you remember the comparison between electron mass and mass of proton? Nearly 1080 electrons mass is equal to 1 proton mass. If you keep 1 proton in the plate of one balance one side, and you have to keep more than 1000 electrons on the other pan to balance the single proton. So, we have almost 114 atoms so far found. That means 114 elements are known to us. 112, the properties of 112 elements were clearly known. The properties of 2 elements are to be evolved. In the 114th atom, there will be only 114 atoms. It is very, very negligible compared to one single proton. So, if there are 114 protons in that atom, what is the mass of 114 electrons? It is a negligible one. That is why we consider protons and neutrons mass as a massive part of the atom. The nucleus contains most of an atom's mass. It was discovered by Rutherford. Who discovered nucleus? Rutherford. So, among the options you have to select this one. So, what is isotope? How to answer the questions basing on this concept, isotopes. See, this is hydrogen. In hydrogen atom, generally most of the hydrogen atoms possess 1 proton. There will be no neutrons present in the hydrogen nucleus, but there are some hydrogen nuclei or hydrogen nucleus possess 1 neutron along with 1 proton. So, 1 proton plus 1 neutron, the mass changes, the mass number will be 2. Hydrogen, the properties will not change, the chemical properties, of course, the physical properties also will not change, but the physical terms, the mass number will change. In some of the hydrogen atoms, such hydrogen atoms also occur in nature, which are having 2 neutrons, 1 proton and 2 neutrons. It is another hydrogen isotope. It is called tritium, deuterium and tritium. A hydrogen nucleus having single proton is called normal hydrogen. The hydrogen nucleus which possesses one neutron is called deuterium, and if the hydrogen atom possesses two neutrons in its nucleus, it is called tritium. So, H1, H2, H3, the mass numbers. What is the electron cloud model? We have seen J.J. Thomson model, Rutherford model, plum model, like that. The electron cloud model. This model of the atom pictures the electrons moving around the nucleus in a region called an electron cloud. The electrons are revolving around the nucleus with a tremendous velocity, 3 into 10 to the power of 5 kilometer per second. So, we cannot identify or we cannot visualize, we cannot distinguish or locate the position of electron at any time. Just you take one small stick of your broomstick, one thin stick, you try to shake it. If you shake it, how it appears like a wide region. You cannot see a single stick, or even you move your finger like this. If you move the finger very fast, rapidly, you can see a wide range, a space. This is called a cloud of my finger. So, when the electrons are moving with tremendous velocity, it makes a cloud around the nucleus. The electron cloud is a cloud of varying density surrounding the nucleus. Why the density is changing in the cloud? Sometimes number of electrons present in one area at a particular location will change. Maybe sometimes there will be no electron present in that area. So, the density of electrons will change. The varying density shows where an electron is more or less likely to be. So, ఎక్కడైతే ఎలక్ట్రాన్ ఎక్కువసేపు తిరగడానికి అవకాశం ఉందో, the possibility or randomicity or probability for the electron to move around the nucleus for longer duration, it is called the thick or high density portion. That is represented as orbital shape. Atoms with electrons in higher energy levels have additional electron clouds of different shapes that also shows where these electrons are likely to be. So, this is the electron cloud picture. See, there are 3 protons and 3 neutrons. That means a lithium atom. In lithium atom, the electron cloud appears like this. It is a cross section. Imagine the cross section. Of course, atom cannot be intersected. It is not an apple to cut into 2 parts. It is a tiniest one which cannot be seen. Even though if we imagine the shape, you can see like that. The early model of atom, significant discoveries occurred since Dalton time. So, J.J. Thomson, previously Dalton, then Rutherford, they formulated or they postulated different versions, different theories. Significant discoveries occurred since Dalton's time that seriously changed the way people envisioned the atom. A summary of the early model of the atom will appear when you click the mouse button. So, I am clicking the mouse, see. So, billiard ball model. What is the billiard ball model? It is a Rutherford model. Elastic bodies, he explained. So, nearly 100 years back, Dalton billiard ball model was the accepted model. But what are the drawbacks in that? the positive charge, negative charge cannot stay together. That's why it was discarded, and then Thomson rectified the problems in Dalton's model. The plum pudding model, J.J. Thomson, during 1856-1940 he lived, J.J. Thomson. He proposed the theory, plum valve model, or fruit bread, you can consider like that, or watermelon, whatever it is. How J.J. Thomson evolved that theory basing on this cathode tube experiments. Discharge tube, it is called discharge tube. It is high voltage. When the voltage is passed in very less density air, it is a vacuum, almost vacuum. In the vacuum, very small number of air particles, maybe hydrogen or some gas. We can fill the vacuum tube with the gases. He filled the vacuum tubes with different gases in very low density, and he conducted experiments, and then he realized some theories, postulates, and he defined the atomic model in his own way. William Crookes was the first to discover these negative rays. Who invented negative rays? What is the relation between this J.J. Thomson model and this Crookes? Actually, Crookes first prepared the Crookes tubes, that is vacuum. In vacuum, the high voltage electricity is passed. Basing on these Crookes experiments, later the atomic model was established. That's why it is also important for us. We have to remember this Crookes tubes. Then electron. Millikan, he conducted the experiments. It is called Millikan oil drop experiment. When a oil drop is put on a paper, tissue paper, it spreads widely. If you take a pin mass of oil, just you immerse a pin into the oil, any oil, maybe kerosene or some coconut oil, and put it on the tissue paper. Immediately you can see the spreading of oil. The oil will spread into a circle. That means the particles are the atoms, the oil molecules will spread widely. When the oil spread widely, we can see the patterns when X-rays or positive rays or cathode rays are shooted onto the oil drop strain, that is stain, మచ్చ చుక్క మీద లేదా ఆయిల్ డ్రాప్ ఎక్కడైతే సర్క్యులర్ షేప్లో ఉందో దాని మీద నుంచి మనం లైట్ ఫోకస్ చేస్తే ఎలా కనిపిస్తుంది. బేసింగ్ ఆన్ దిస్ కాన్సెప్ట్ దే కండక్టెడ్ ద ఎక్స్పెరిమెంట్స్, అండ్ రాబర్ట్ మిల్లికాన్ tried to calculate the ratio, E/m ratio. What is E? Electron charge and mass, electron charge and mass. So the charge mass ratio was calculated as 1.759 into 10 to the power of 8 coulombs per gram. From this the mass is calculated, because we know the electron charge. So by applying that electron charge, we can calculate the mass. The mass of an electron is calculated as 9.07 into 10 to the power of minus 28. See how small, how less number it is. it's not a gram, it is not a milligram, it's 19 10 to the power of, it is not 19, 10 to the power of 9.07 into 10 to the power of minus 28 grams. So, planetary model. What is planetary model? Rutherford, whatever he established, that is named as planetary model. How the planets are revolving around the sun, in the same fashion the electrons are revolving in a fixed orbits or fixed shells around the nucleus. The electrons are revolving. That is why it is named as planetary model. So, this is the Goldfile experiment. If this diagram is given and a question is asked like that, what this experiment represents, who did this experiment, like that questions will be asked, or labeling also. It is a Goldfile. So, I told you, just 2 to 3 electrons layer or atoms layer. Let us consider this as a layer of atoms. This is another layer of atoms, this is another layer of atoms. The size of atoms is very less. So, the thin file, very minute thickness, that file is taken, and when the helium nuclei are shooted over this file, they were scattered. See, some nucleus, some helium scattered, and most of them are passed through the file, the proton, the information about the proton. The mass of proton is 1800 times over the electron. The mass and charge of different particles, some questions may be selected from this part also, and from isotopic concept some questions may be asked. This is a hydrogen isotope, deuterium, tritium. Different isotopes of different atoms. Lithium is having some isotopes, it is called lithium 6. Magnesium, magnesium 24 is another isotope. Basing on mass number, whether it is isotope or normal magnesium, that may be asked. So, if you thoroughly prepare with the concepts, if you read the lesson thoroughly, whatever question in whatever way it is asked, you can answer it very easily. See, how many neutrons are there in this isotope, if it is asked like that. How to calculate that one? How many neutrons are there in this isotope? Generally, magnesium, the atomic number is 12, there will be 12 protons, 12 neutrons. So, it is atomic number, mass number minus atomic number gives the proton number. Tungsten is having atomic number 74 and mass number 184. So, 184 minus 74, 110 neutrons are present, once the 74 electrons are present in tungsten. W means the atomic symbol tungsten. Lead, and the table may be given, some gaps or some boxes will be kept empty, and you have to select the appropriate numbers from the given answers. You have to choose the appropriate answer. The table will be given with some gaps. Write the isotope notation for the element chlorine with atomic number 17 on the periodic table. If the periodic table is given, how to represent it? Chlorine has a number that is a decimal. So, why the mass number of chlorine is not a whole number? It is represented as 35.5 because of the average mass of isotopes. That answer you have to select. So, mass number versus atomic mass. Atomic mass is shown on the periodic table. So, the symbol of elements will be given, and average weights and the exact weight average, such things may be asked in the questions. Mass of isotope 1 into percentage of abundance. ఎంత ఐసోటోప్ పదార్థం దొరుకుతుంది మనకి ప్రకృతిలో అనే దాన్ని బేస్ చేసుకుని, అంటే 100 గ్రాముల కార్బన్ తీసుకుంటే అందులో 20 గ్రాముల ఐసోటోప్ ఉందనుకోండి, రిమైనింగ్ పార్ట్ 80 grams of substance is having mass number as 12, and the remaining part 20% is having higher mass number. So, we have to consider the average. So, mass of isotope 2 into percentage of abundance, like that. So, average atomic mass, how to calculate it? Basing on this slide, some questions may be asked. Relative abundance of magnesium, atomic mass of magnesium, the accurate mass, like. So, these are some of the questions can be framed from this portion. Let us discuss about the chemistry part of atomic structure in the next session.